So if I have a not equals condition, if my values fall below -2 or above 2, or outside of plus or minus 2 standard deviations, that is in the 5% most unlikely, and so I would consider them sufficiently unlikely that I would reject my null hypothesis. Now, there's a little bit of a hitch to this in that if I'm looking at, for example, a less than condition, in a less than condition, I don't care about the positive side. I only care about this side. Okay? So if I do that, I don't care what goes on over here. I only care about this side. And so what I'm really looking for is I'm really looking for the lower 5%, which is a little bit higher than this. Or I could say this is just 2.5% here. But it's basically the same idea. So I'm looking only for what we would call a left tail. And we'll get more formal about this as we go along. But the idea is we're looking for the data which is the most unlikely 5% or the most unlikely 1% or 10%, whatever we set that percentage point at. By default, that value is 5%. If I don't tell you otherwise, assume it will be 5%. Later on, what we'll call this is alpha, and we're going to say that our value of alpha is going to be 5% unless stated otherwise. Okay? Is that making sense? Seem to fit with the way you'd actually do things normally? You might not say it was 5% though. We wouldn't calculate the likelihoods in our heads. Actually, I think we do. I think we naturally do this, and we probably do it in a fairly accurate fashion, but we don't think about it that way. There's a problem with all this, though, isn't there? I said that I'm going to reject this null hypothesis if my observation is in the most unlikely 5% of my data. Does that mean that I'm absolutely positive that the null hypothesis is false? I just said it's in the most unlikely 5%, but I also said that there's a 5% chance that it could be there normally. Okay? Whenever you're doing any kind of testing, on Monday we talked about confidence intervals. We recognize that the confidence intervals don't always capture or don't always straddle the true population parameter. That's also true with hypothesis tests. There's a possibility of being wrong. There's a grid we used to describe this. So we have a true condition of the world is either the null hypothesis or the alternative hypothesis. The test then comes out with either a null hypothesis or an alternative hypothesis. If the state of the world is the null and we do not reject the null, that's good. That's exactly where we want to be. If the state of the world is the alternative and we reject the null and say the alternative is true, that's also exactly correct. So these are the correct conditions. These are errors. So if the state of the world is true and we reject the null hypothesis, that's what we call a type 1 error. Type 1 error is rejecting the null hypothesis when in fact it is true. If we look at it in this case here, that would be saying that somebody is guilty when in fact they are innocent. Okay? A type 2 error is failing to reject the null when in fact the alternative is true. Or again, back in this case, that would be letting somebody that's actually guilty off and saying that you think they're innocent. Okay? Or in our court system, it's probably better to say not that they're innocent, but rather that there is sufficient evidence to show that they're guilty. Okay? We don't necessarily know for a fact that they're innocent. We only know that we have not sufficient evidence to say that they are guilty. That's exactly the way our hypotheses are working. Now, aside from recognizing this as how we learn, what else is this? Does this look at all familiar? Did you take science classes to get this far? Yeah. This is the scientific method. This is the core of science right here. All science is done this way. And that's all we're doing here is we're implementing the scientific method. Next time I said
I just want someone else to talk.
So, we have 15 minutes. We actually have some time. Take a look at 12:11. Talk over, write down the hypotheses. These are a number of situations where they want you to state the null and the alternative hypothesis. And a little before, actually, take about a little more than 5 minutes doing that. And then we'll start talking about these as a class.